Hello guys and welcome back to the reaction zone. In today's lesson we're going to look at the laws of electrolysis. There are two laws that govern electrolysis, and these two laws are propounded by a scientist called Michael Faraday. Faraday's first law of electrolysis states that the mass of a product of electrolysis is directly proportional to the quantity of electricity that is passed. So mathematically speaking, Faraday's first law can be represented as M is directly proportional to Q, where small letter m represents the mass of a product of electrolysis, or you can call it the mass of substance deposited, and capital Q here represents the quantity of electricity that is passed. Now, this equation here can further be simplified. First of all, it's important to note that the quantity of electricity is equal to the product of current represented by I and time. So it means that this equation can be written as mass is directly proportional to IT, where IT, which is the product of current and time, represents the quantity of electricity. So we can call this equation 1, for instance. And then let's come down to Faraday's second law. Faraday's second law says that when two or more electrolytic cells are connected in series, that the mass of each product of electrolysis is directly proportional to its chemical equivalent. So, in the illustration that we can see here, this is one electrolytic cell and this is another. They are both connected in series, and each of these electrolytic cells gets the same quantity of electric current, or the same quantity of electricity, which is represented by Q here. So, in the first cell we have electrolyte A, and in the second cell we have electrolyte B. According to Faraday's second law, that the mass of A that will be deposited will be directly proportional to the chemical equivalent of A. The chemical equivalent is generally represented with the symbol capital E. And then for cell B, the mass of B deposited is going to be directly proportional to the chemical equivalent of B. So, mathematically, Faraday's second law can be expressed as mass is directly proportional to chemical equivalent, which is represented by E. And this is our second equation. It's also important to know that E, which is chemical equivalent, is equal to capital M over N. Now, capital M here represents atomic mass, whereas N here represents the charge on the atom, or the valence. So, I'm going to combine the mathematical equation for these two laws because I want to generate a formula that can be used to find the mass of a substance deposited when all other parameters are known. It is a formula that can be used to solve most of the problems on electrolysis. Now, if I combine equation 1 with equation 2, I would simply have M is directly proportional to EIT. So we can call this, for instance, equation 3. Now, this particular expression that is here, where E is equal to M over N, I can call it equation A, because I'm still going to come back to it. Now, when this proportion sign here changes to an equality sign, N becomes equal to EIT over 96,500. Now, 96,500 coulomb, which is what this represents, is known as Faraday's constant. And Faraday's constant simply refers to the quantity of charge in 1 mole of an electron. So what this means is that 1 mole of an electron has 96,500 coulombs of electricity or electric charge. Now, having done this, if you call this equation 4, from equation 4, E over 96,500 is the same thing as Z. And what exactly is Z? Z is called the electrochemical equivalent. It's called the electrochemical equivalent. And what this means is that in place of E over 96,500, I can put Z. And when I do that, my equation 4 is going to become N is equal to ZIT. Now, we can actually call this one here equation 5. Now, before I continue with my derivation, it is important to state clearly at this point that chemical equivalent and electrochemical equivalent are not the same. In other words, capital E, which is chemical equivalent, and Z, which is electrochemical equivalent, refer to 2 different things. They are not the same. Now, let's start with E. E, which is the chemical equivalence, simply refers to the mass of a substance that reacts or is produced when 1 mole of an electron is involved in a chemical reaction. Whereas Z, which is the electrochemical equivalent, simply refers to the mass of a product of electrolysis that is formed when 1 coulomb of electricity is passed. So, there are 2 different things. They are not the same. Having said that, we can continue with our derivation. Now, if you look at this particular expression here, where E over 96,500 is equal to Z. Now, let us not forget that when you look at equation A here, that E is the same thing as M over N, where I said the capital N is atomic mass and N here stands for charge on ion or valence. So, in this particular expression here, I call it equation B. I can actually decide to replace E with M over N and put it in this particular equation. So, if I do, it means that this equation here will become N over 96,500 N is equal to what? Z. So you can call this here equation 6. Now, this was obtained by replacing E in equation A with M over N. So if I replace E in equation B here with M over N, I will get this. Now, from equation 5, I can actually make Z the subject. So, this means that from equation 5, if I make Z the subject, Z is going to become N over IT. So, you can call this equation 7. So, we can see that according to equation 6, Z is equal to N over 96,500N, and according to equation 7, Z is equal to M over IT. So if I decide to equate equation 6 and equation 7 together, so that is equating equations 6 and 7, it means we're going to have N over 96,500N is going to be equal to small letter m over IT. So if I decide to make the small letter m the subject, it means I will have small letter n is going to be equal to MIT over 96,500N. So, this particular equation here can be used to find the mass of substance deposited, which is represented by small letter m, if all the other parameters are known. Now, it is important to state clearly what each of these things here mean. The capital letter M is the atomic mass. Capital I stands for current, whose unit is in amperes. T stands for time, and the unit must be in seconds. And then N stands for the charge on ion, or it stands for valency. It also stands for oxidation state. So with this particular equation that is here, you can find the mass of the substance deposited if all these other parameters are known. Now, if we go back to this point here, remember that Q is equal to IT. So it means I can replace this IT here with capital Q. And like I said, 96,500 is the value of 1 Faraday, which I have already mentioned before. And I have told you that 96,500 coulombs, which is 1 Faraday, simply refers to the quantity of charge present in 1 mole of an electron. So, if I replace IT with capital Q, and I replace 96,500 with 1 Faraday, it means that this equation here will become N is equal to NQ over NF. So, with this equation, or these other expressions here, you can actually find the mass of substance deposited, which is represented by small letter m, if all these other parameters are known. Now, finally, it is important to state that the small letter n, which is mass of substance deposited, must always be in grams. Small letter m, which is mass of substance deposited, must be in grams. So I want to believe that you understand Faraday's law of electrolysis. And that you also understand how we used the mathematical expressions for the two laws to actually get a formula that can be used to find the mass of substance deposited when all the other parameters are given. Thank you very much for watching, and see you in the next one.